Hello friends! In this lesson we are going to see how we can have a flashing button. Then we will see how we can use function keys and manage users on an HMI screen. Let's start with the previous project. For this tank we have written a PLC program, and this is the designed HMI screen with a little modification. Here we have only two screens, the start and the tank screens. Remember that we can enter the desired level in the automatic mode. In manual mode, we can fill and drain the tank with the related buttons on the HMI screen. At the bottom of the HMI screen, I have inserted two buttons for that. Now let's see how we can have these flashing buttons. Let's go to the tank 1 screen. Now select the discharge button. In its properties window, select its animation tab. As you can see, this button is linked to the discharge push button tag, and also I have defined two colors related to the two states of the link tag. For the second color, I have enabled the flashing ability. Also, the fill button starts flashing when the related tag value is 1. Notice that here we have 4 function keys: F1, F2, F3 and F4. These function keys can be used to either actuate an input, change an activated screen, or for any other purpose like buttons. The basic idea behind these function keys is that we can use them as a local or global assignment. Let's define a local function. For example, tank filling for F3, like its upper fill button. This is very simple. In its event tab, select this function and connect it to the fill tag of the PLC program. Also, let's use F4 key for tank discharging. As you can see, when a function is defined, a yellow triangle will be shown on the related function key. Alright, here instead of these buttons, let me use a graphic to show my function keys task. For example, select F3 and in its properties window, here select a graphic for that. Now let me remove the inserted graphic. We don't need it because we understand the F3 task with its upper button. Well, let's go to the main screen. As you can see, on this screen the F3 and F4 keys don't have the yellow triangle. So we can define new functions for them. Let me use the log on and log off functions, which will be explained later. Now let's test our HMI screens. Alright, as you can see, the logon button and the F3 key open the login window on the start screen. In the tank screen, the F3 and F4 keys can be used to fill and discharge the tank. So F3 and F4 keys have different tasks on each HMI screen. This way of using function keys is called a local assignment. On the other side, we have a global assignment. In this state, function keys will do one task on all HMI screens. Now, let's use F2 to open the tank screen and F1 to open the start screen. First, let me activate the Use Local template for F1. As you can see, for F3, this ability is inactive. Otherwise, its local function will be inactive and then it will use the global function. Alright, let me return to the local assignment state for F3. Well, let's activate using local template for F2. Now let's go to the screen management and select global screen. Here we can define global function. So we want to activate the main screen with F1 and open the tank screen with F2. As you can see, in this case, a green triangle will be shown on F1 and F2. Like local assignment, here we can define and use a graphic for F1 to F4. Let's get back to the tank screen. As you can see, the F2 doesn't have a green triangle because I forgot to activate its global assignment. Let's start the simulation. As you can see, we can activate the start and tank screens with F1 and F2. Also, we can use F3 and F4 for tank filling and draining in the current screen, or use F3 and F4 to log on and log off on the start screen. Alright, until now we have seen what the basic objects and elements are. Now we are going to see what is here under the controls menu. Let's start with the user view. Let's insert it into the main screen. With this table, we can define a password for each HMI user which have a different level of authorization. Let me resize this table. Now let's go to user administration. Now select user groups. Sometimes you will notice when you log onto your HMI screen, there are different users. One user is for the admin, one is for the operator, and one is for the system viewer. Actually here, all HMI users have been divided into 3 groups. In the second table, we can determine each group's authorization. For example, here the viewer group just monitors the industrial process on HMI device. Operators can monitor the industrial process on the HMI and also do some work such as press a button or change a number. And the admin group has all of this access ability. To define users, click here. In the first table, we can define new users and their passwords. In the next table, we can determine each user belongs to which group. For example, Reza belongs to the operators group. Let me define another user. The next user, Wahid, belongs to the operators group too. Let's insert another user. I changed the last user group to the viewer. So here we have one admin with full accessibility, two operators and one viewer. Here we can determine a time if the automatic log off is enabled. For example, if the first user admin doesn't do anything for 1 minute, HMI will log off this user automatically. Let's get back to the HMI screens. As you know, the HMI starts its work with this screen, so everyone can see this screen. Suppose just 4 defined users are allowed to see the tank screen. So we must go to the security part of this button. Here we must determine the selected button needs which authorization. I select the monitor authorization. Remember, all the 3 defined groups have monitor authorization. So all defined users can work with this button and go to the tank screen. Let's go to the tank screen. Suppose just the admin user can switch between the auto and manual control mode. So in its security part, I select user administration. Remember, only the admin group has this authorization. Now suppose the admin and operators group are allowed to work with this element. So I select operate authorization in their security parts because just these 2 groups have this authorization. Alright, let's test the design HMI. First click on the user view table. Let me log on as admin, which has the full accessibility. As you can see, I can see all user information and change all user names, passwords, user groups and log off times. Now let's log on with another user. Now let's go to the tank screen. As you can see, it needs a user and password, so everyone cannot see the tank screen. Let's use the Wahid user, which belongs to the operators group. This user cannot use the auto manual switch. Only the admin can change the switch, but this user can monitor and control the liquid level. Similarly, I can test the program with my PLC and HMI. As you can see, for the first time I cannot go to the tank screen. I need to use a predefined account. Now I can change my log off time or go to the tank screen and change the desired level. Note that I cannot change the control mode as an operator. Only the admin account can change this item. So let me use the admin account. Now I can change the control mode from automatic to manual. Also, the admin can fill or discharge the tank manually. Also, the admin account can manage other accounts. Well, each user can log off when pressing this button. Now let's see the trend view, data logging, internal tags, and how we can see an internet page on the HMI screen. First, let me show you these abilities. When there are many HMI screens, we don't have to use a button to open each screen. We will see how an HMI memory can be used to create this list. On the tank screen, we will use a trend view to see the liquid level diagram. Also, we can store these or other parameters with the data logging option. It stores industrial process parameters in an external source. Finally, we will use an HTML browser on the HMI. Let's start the video with this screen from the previous video. Now let me insert a trend view from the right list. Like other elements, at the Properties window we can change its setting. Here we can define new trends. The main part is this column to determine its linking tag. Let me select this tag which stores the liquid level in my PLC program. The cyclic time is a periodic time in which a trend reads and shows the selected tag value. Also, we can change other settings like its trend data type or its range. Here we can change the trend style or its color. Alright, let's go to its time axis and change it to 10 seconds. Now let's test the inserted trend. Okay, I need an account. We have created them in the previous video. Let me go to the Trend Properties window and remove the below table. Let's test the HMI screen again. Now instead of the previous table, I can stop the trend view or magnify that. Alright, let's see how we can store some industrial process parameters such as the liquid level on my computer or on an external memory. From the left window, I select historical data. Let's specify a name for the new data log. Then I can change its settings like the output format, the number of data records to be logged in each data log, the paths where the log entries are saved, or check this box to start data logging automatically. Also, I can select the restart behavior of the log in this column, which is keeping or clearing the previously recorded data log. Here we must determine data values that we wish to log. First, I want to record the tank liquid level. Then its PLC tag must be entered. Also, we can determine the logging cycle time. Also, let's define its lower and upper bounds and select its log limit ranges. Naturally, we can log more than one parameter. Now let's test the design HMI screen. Let's select the automatic mode and enter 90%. Then the fill valve will be open until the liquid level to reach the desired value. During this simulation, the HMI stores the liquid level and the fill valve value on the drive C of my computer, here in this file. As we can see, every 5 seconds, 2 tags of the PLC are recording here. To see the updated data, this file must be closed and opened again. Alright, data logging is used to have a backup of industrial process information. The designed HMI screen can be improved, like this screen. Here the data logging can be started, stopped, and cleared manually. Let's see how this HMI screen has been designed. First, I use the trend view to create a new screen. The main part is the 3 inserted buttons which are using suitable functions in the Events tab. For the Start button, I selected the Start Logging function. I use the Stop Logging function for the next button, and I use the Clear Log function for the third button. Finally, here we have a simple circle to show the data logging state. The circle is linked to this tag, Logging LED. If its value switches to 1, then it starts flashing. The logging LED value is changed by the Start and Stop Logging button. As you can see, this button does 2 works. When it is pressed, data logging will be started and the logging LED tag is set to 1. The next button stops data logging and also resets this tag. Here is a question where the logging LED tag is defined. Like the previous videos, we can use a bit of PLC memory, but here the HMI memory can be used as well. Let's go to the HMI tags table. Here we can see all linked tags which have been defined before. These tags can refer to addresses on a PLC or use the HMI memory. Here the logging LED tag is defined and the internal tag is selected for that. So this tag uses the HMI memory. Let me show you another example of using internal memory. Let's define an internal tag which its data type is integer to store integer numbers like 1, 2, and 3. Now let's go to the main screen. Here I have inserted another button to open the trend and the logging screen, which we did it before. Now we are going to use an I/O field element instead of using a button to open each screen. In the inserted element properties, I use a defined internal tag. Also, I use a text list which has been defined before. This text list has 3 choices related to the 3 screens. Pay attention. By checking each screen property, you'll notice that each screen has been assigned a unique number like 1, 2, or 3 that it is used here. Now, in this Event tab of the Inserted I/O field, select the Change option and then select this function, Activate Screen by Number. Now, link this function to the defined internal tag. Let's copy this I/O field in other screens. So when we use this I/O field to change its connected text list, the number which is stored in the connected internal tag will be changed as well. Also, we have used the function to select and open screens based on the number which is stored in the defined internal tag. Now let's test the HMI screens. As you can see, I can change the HMI screen with this list. Let's define another screen to use the HMI browser on the HMI. Now, we don't need to use a button to open this screen. As you can see, this screen number is 4. We just need to modify the text list which is used in this I/O field. So let's go to the text and graphic lists. Here I define the 4th screen. Now let me copy the I/O field and paste it into the new screen. Also, let me use an HTML browser inside the new screen. So anytime that the HMI is connected to the internet, we can see this internet address on the HMI. Let me change its default address. Let's test the screen. As you can see, I can go to the new screen with this list. Also, I can view the inserted internet address. Let me search the PLC Goods website on the HMI. Test this subject on your own if you have a PLC and HMI. When I activate data logging, its data is stored in the HMI memory. Alright, in the next video, we will start to learn different system controls which are usually used in the industrial process. After that, we will continue learning to control menu items like recipes and alarm views. Thank you for watching this video.